Hello everyone, welcome back to our channel Indra Educational Academy. In continuous of Java concept, we are in the unit 4 and in previous units we learn about introduction and operators, statements, etc. Whereas in unit 4 we are going to discuss multi-threading, that means threading of program, how the threads are used and life cycle of thread, advantages, all these are discussed in this unit 4. So without let us begin our class. So coming to the term, coming to the concept multi-threading in Java. Before going to learn about the multi-threading of Java, you should learn about the meaning of the term thread. So here it is the definition of the thread. A thread is a lightweight subprocess, the smallest unit of processing. It is a separate part of execution. Threads are independent. If there occurs expectation in one thread, it doesn't affect other threads. It uses a shared memory area. Here what this definitions means, thread is nothing but a process which process subprocess. That means all the threads are used within the program. So thread is a subprocess, not the complete process but subprocess. That means half of the part programming is depend on the thread only. So thread is nothing but a subprocess. That means very small process, small unit of process. It is a separate part of executions. If you use thread in Java program, then the part of execution is little bit different from the simple Java program. And here threads are independent. It doesn't depend on other parts like classes, objects, or whatever maybe. There are independents. It doesn't affect. It uses a shared memory area. Threads use it to share a memory area. So this is the definition of the thread. And coming to the graphical representation of thread, here T1 is a thread, T2 is the thread, T3 is the thread. Once check the process 1. Here process 1 consists 3 threads and they are interlinked one and each other. Whereas coming to process 2, 3.1 and 3.2, they are interlinked with each other. Whereas process 3, it consists only thread 1. So this is the graphical representation of thread. So now life cycle of a thread. A thread can be in one of the 5 states according to the Sun. There is only 4 states in thread life cycle in Java: new, runnable, non-runnable, and terminated. There is no running state. So here life cycle of thread, that means thread is a sub process. So that process here, life cycle of thread is nothing but the process which executes in how many types is a life cycle of thread. So the process of thread executes in new, runnable, non-runnable, and terminated. So here the types of the thread is also new, runnable, non-runnable, and terminator. So let's check the graphical representation of life cycle of thread. This is the graphical representation of life cycle of thread. If the thread question comes for essay or 10 marks, we must include this graphical representation also. So here checks new, runnable, running, terminator. Here new is nothing but start. That means intersecting the program. That means you write a code and that program is going to be run. Next one, runnable. That means the program which is intersected by you or which is created by you is runnable. That means getting ready to run. Whereas running, that means processing. Running is nothing but processing. That means compiling the data. Whereas terminator is nothing but giving outputs. If the given conditions are not accepting, then it exits. That means terminated. Again go to the loop section. So this is the graphical representation, and the definitions of that concepts is new. The thread is a new state if you create an instance of thread. Here instance is nothing but adding or intersecting class, but before invocation of start method. So before going to start the method we intersect this new thread. So this is the graphical representation of new thread. Very important ma. Next to runnable. Definition of runnable and running. Coming to runnable, the thread is in runnable state after invocation of start method, but the thread scheduler has not selected it to be running method. Running thread. So here what is that? The thread is in runnable state after invocation of start method. So in new, before starting method only we are using that new, whereas runnable is after the invocation of start method. That means after the method we are using this runnable thread, whereas running is, it is scheduled. The thread is in running state if the thread scheduler has selected. Here running is within that method running thread is used. So this is the graphical representation of runnable and running. Once check clearly. Non-runnable means blocked statement. In this is the state when the thread is still alive but currently not eligible to run. That means we are using threads in the program, but the program which is used by the threads is not running. So due to lack of running, it doesn't execute. That all types of programs comes under the non-runnable statement. That means non-runnable threads only. That means block threads. Terminated is nothing but dead state. When its run method executes, that means when the program exits, that means the given thread program is totally exits, then it's become the terminated thread. Next, how to create a TED. There are two ways to create a by extending TED class by emulating runnable interface. So in two methods we are going to creating the thread by extending. That means by enlarging the thread class we are creating thread, and by implementing runnable interface. Here interface is, what is the interface? Interface is nothing but a object, that means which consists the object is known as interface. So thread class provide constructor and methods. So in thread class we use constructors and methods to create the thread program. Commonly used constructors of thread classes, these four are commonly used method: and public void run, and public void start, public void sleep, public inset priority. All these are used in programming only. When you using programming or when you are writing program, all these terms are used in programming section only, not in theory section. So these are all comes under the programming section only. That means in the syntax of program you saw all these programs by extending a thread class. This is the second method of creating the thread class. Define a class which extend thread class and override it. So by defining a class name and overriding that class name, this process is extending a thread class. So this is the thread class declaration, that means syntax. Next topic is Java thread example by extending. This is the example for extending thread class. Output of that, here by implementing runnable interface. So define a class which implements runnable interface. The runnable interface has only one method, run. So here runnable interface consists only one method only. So by using that one method only we are creating threads. That comes under to the implementing runnable interface. So this is all the examples of that, and this is the example for running implement interface. Priority of a thread. This is the other concept of the thread, priority of thread. So here priority of thread is, priorities means nothing but importance. So here once come to that definition, each thread have a priority. It's true. Why? Because each thread have unique functionality. So like that, priorities are represented by a number between 1 to 10. In most cases, thread schedules the threads according to their priority. So according to their priority, that means according to their importance only threads or execute. That comes under the priority of a thread. Here three constants defined in thread class, that is minimum priority, maximum priority, and normal priority. Example of priority of a thread and output of that priority of thread. Next, thread synchronization. When two or more threads access to share a resource, there need some way to ensure that resource will be used by only one thread at a time. The process by which it is achieved is called we can synchronize our code in two ways. So here, when two or more threads wanted to access common data, when two or more threads wants to access only one common data, then this thread synchronization is used. So here two methods are there. One is methods and code blocks. This is the syntax for that methods. By accessing methods to one at a time, in this methods at a time we access that all the data. Simply we need some keywords. And next one is code blocks. By indicating objects, in this by indicating objects we are going to access the data. Interthread communication in Java. This is another method, another topic in this unit. For interthread communication in Java is all about allowing synchronization threads to communicate with each other. It is implemented by following methods. So these are the methods to intercommunicate with threads in Java. So interthread communication is nothing but communicating with each other threads within the program is known as interthread communication in Java. So by using these below methods, we are communicating the threads internally. So wait method is one method. This is the syntax of that. And notify method, syntax for that notify method, notify all method. By these three methods, by using these three methods, we are using interthread communication in Java. Next one is multi-threading in Java. Up to here we learn about threads. Up to here we learn about threads. That means threads, life cycle of thread, how to create threads and thread class, priority of threads and thread synchronization and methods. So now coming to multi-threading. Multi-threading in Java is a process of executing multi-threads simultaneously. That means repeatedly. A thread is a lightweight subprocessor. In a starting section, we read this sentence. Thread is nothing but a lightweight subprocessor, the smallest unit of processing. So multi-processing and multi-threading both are used to achieve multitasking only. Here multi-processing and multi-threading is used to work the multitasking only. So here multi-threading is a sub-process to execute multi-threads. That means more programs, more than two. Here advantages of multi-threading. Difference between multitasking and multi-threading. Next concept is error. Error is nothing but a mistakes. When we compile the program, Java program, the source code converts into bytecode, and that bytecode to that bytecode the machine checks the errors and it displays the errors in source code. So error is nothing but mistakes in our program while developing a program or typing a program. It may here once read that definition. It is common to make mistakes while developing as well as typing a program. A mistake might lead to an error causing to program to produce unexpected results. So when you simply write a program, in that program by mistakenly either symbolic or statements or methods or classes at whatever at any place we make an error. So these errors are identified by this error software in Java. So it is used to identify the mistakes while developing a program or writing a program. So types of error, compile time errors. Here compile time errors is nothing but mostly these types of errors identified at the time of compiler. That means semicolons or brackets or identifies, that means identifies and keywords, double quotation in strings, undeclared variables, all these mistakes, that means the mistakes which happen at semicolons, brackets, identifies, double quotates, undeclared or comes under the compile time errors. Whereas runtime error is during the program executions, when the program compiler and it's get ready to execute. At that execution, sometimes the user didn't get the program output. At that time, runtime error will be displayed. And logical error, if logical is nothing but mathematical expression only, arithmetic and logical, whereas arithmetical is mathematical and logical is mathematical symbols. So here logical errors is nothing but the errors which are occurred in mathematical mathematical symbols or mathematical formulas, when the user uses wrong formulas. So by using logical errors, the errors are displayed. So these three are types of errors. And next one is exception handling. Exception in Java and exception handling. In Java, an exception is nothing but an event that normal flow of program. It is an object which is thrown at runtime. So exception is nothing but an object that thrown at runtime. And exception handling is a mechanism to handle runtime errors such as class not found. So in previous we discussed about runtime errors now. So to overcome that means to handle that runtime errors, Java introduced the exception handling concept. So this is the graphical representation of error and exception. Once clearly observe that. And the next one is advantages of exception handling. Next one, Java acceptation keyword. So this is the acceptations keyword: tie, catch, finally, to pose. So the general form of an exception handling block, that means general form is nothing but syntax. Here is the example for that Java acceptation keyword. So this is the output for that one. And graphical representation of Java expectation keyword. So Java expectations of two types: built-in expectations, user-defined expectations, checked expectations. Types of Java expectations: checked expectations. So checked expectations means runtime exception and error are known as checked exception, whereas unchecked exception is inherited. Whereas coming to checked exception, the classes which directly inherits table class, whereas coming to unchecked, the classes which inherit runtime exception. That means here unchecked, the by using classes it is inherited runtime exception, whereas coming to checked exception directly inherits the runtime expectation. Next one is error. Error is a irrecoverable. Out of examples for that error is predefined expectations, arithmetic array index out of boundaries, class not found expectation, file not found expectation, IO expectation, entrepreneur expiration, no such field expiration, and no such method expectation, null pointer expectation, number format expiration, runtime expectation, string index out of bounds expectation. So these are all types predefined expectations. Predefined expectations is nothing but pre-installed expectations. Here user defined expectations is based on user requirements. These expectations are going to be created is known as user defined expectations, or simply we can say that about user defined expectations is the expectations which are created or generated based on the user's requirements is known as user defined expectations. And this is the entire class of the unit 4. Before going to end this unit 4 class, once check all the topics which are covered in the unit 4. So unit 4 is completely based on multi-threading and thread. So before going to multi-threading, thread thread concept is also very important. So thread definition, life cycle of thread, at the same time advantages and disadvantages of thread, and creation of thread. Creation of threads in two ways. Creation of threads is also very important, and graphical representations, examples and syntaxes of that creation of threads. Next one, thread priority. Thread priority, thread snake notation, and the types of that snake notations methods, inner thread communication, errors and types of errors, expression errors and types of errors, and exception handling and types of that exception handling, and advantages and disadvantages of that exception handling, and Java expectation keyword and types of that Java expectation keyword. Here expectations, predefined expectations, and user defined expectations. So all these topics are covered in unit 4. Simply, if you got idea for unit 4, simply in unit 4 thread and multi-threading, whereas errors and exception handlings are there in unit 4. Main topics of unit 4 is thread, multi-threading, errors and exception handling. So this is the concept of Java Unit 4 of Andhra University based syllabus. Thanking you. For more videos, subscribe to my channel. Jai Hind.